This time on Captain Castle's Laboratory, we're working on a Department 56, excuse me, Snow Village Halloween, the Spider House. So, looks like it's from 2013. At least that's what the bottom is. They pulled out a package, and the bottom fell out, which is expected. The person that sent it to me tried to do a little work before they sent it to me, trying to help them fix it so they didn't pay shipping. But from the email, this resistor is burnt, and it's what controls these lights here. This light probably works just fine. So this is a 3-volt house, so 3 volts DC. I have the power cord for the house that says Spider House on it. Let's just make sure it's putting out the right amount of power, because normally for these resistors to burn, it's one of two things: either too much power or a short, which is the equivalent of too much power. So we got 6.45 free float volts. It's a little high, but it's probably fine because this will take a massive amount of the load. So let's plug it in. There we go. Lights on. And I'm just going to check at these joints. If I can get in here. There we go. Apparently I can't. So 3.6. And that's because the light bulb takes a lot of the load. Because the light bulb's on LED, it's incandescent, so it has a much higher resistance, which pulls more of the power down. So technically, the house should be fine with the bulb. So now we need to see what caused this resistor to burn and what this resistor was, power-wise, so we can figure out why lights don't work. These. So, there are a couple of wires hidden inside the house. They're the wires that were soldered to these two joints. I don't want them touching because it'll short out. This will go out and it can overheat the power supply. Which, if it's a quick instant, it won't hurt it. So if you're doing this at home, but if you just hold them together, your power supply will start to smoke and possibly catch fire, and we don't want that. So I'm gonna get my meter back out, and I'm gonna use a magnifier, and I'm gonna see if I can read anything on this resistor. Now this thing is burnt all the way through. It burned all the way down to where you can actually see the resistive wire on the inside. This thing got hot, like real hot. Okay. Now the two wires that are on the inside, I'm going to try and tip this up. Trying to see those two green wires right up in there. Those are the wires that come through the hole in the wall right here, which feed these lights. I don't know if these will come out. It might make it easier to work on if I can pull them out of the hole. Yeah, they'll pull out just fine. Look at that. Bam. So, I know that these lights have to turn on at 3 volts or less. So I'm going to use a power supply. Let me see if I can strip. Oh, those are two smallest gauge, still too big for these wires. Let's rotate this house. Now I'm going to use my power supply. My power supply, I can control the voltage, and if the lights are shorted out, the power supply will give me an audible tone that says, "Hey, doofus, you have a problem." So, let's see if the lights actually work. So I have it set for 2 volts, 2.2 to be exact. So if I touch them, surprisingly, the wires have enough resistance not to set the tone off. That's not right. That's the tone I'm talking about right there. 2.2 volts. I don't know which is positive and which is negative because these wires are the exact same color. So I'm going to just connect one and tap the other. No lights, no amperage draw. So now we're going to connect the other one. You can sometimes do this with a 3-volt lithium battery. I have no lights, no amperage draw. So I'm going to bump up the power to 2. Well, doesn't do it in a half, now it's 2.6. No lights. Nothing. All right, let's go for the full 3 volts. 3 volts. Absolutely nothing. There we go. We got purple lights. We did until it slid off my finger. There you go. And it's pulling 200 milliamps. It's bouncing back and forth between 1 and 2. But let me, there we go. Now I put it exactly at 3 volts. It's pulling 200 milliamps. So most likely what happened is, I bet you this, I don't know, I'm just speculating. Either something touched and this became shorted, which caused the resistor to burn, because at 3 volts directly across power, it will not be able to handle it. It'll just get hot and melt. But at the same token, remember how this was 6 volts until I turned on the light at the power supply? That free float is probably too excessive for these lights. So if we did something like this, imitating a burned out light bulb, the power would spike, causing those to spike. And that's probably what this resistor was for, was to prevent it from spiking. But I wonder if the free float is too high, meaning with no load on it, it's at 6.45 volts, if I remember right. A lot of them only go up like 4.5 volts, not double. You're literally going more than double the power of the head unit or the adapter. So that could be the cause. I don't know. It's a speculation. I don't know why it burned. It could have been just a defective resistor, meaning the resistor is old enough and it's gotten used so many times that the hot and cold cycles from electricity going through it may have caused it to just break down. Inferior. I can only do speculation, because unless you're actually there to see it happen, you don't know. So I'm going to turn off my power supply. I want to take a gander inside this house, because the other end of these wires are inside here too, and I wonder if they touched, like they trimmed it and they touched each other, creating a short. So let's see if I can grab them. That's too short. I need longer. I don't need that long. Need something shorter than that. Drawer full of tools, and I'm looking for my mid-length because I really don't want to use my long, but I guess I will. I'll use a set of hemostats. These things are freaking huge. Just to give you an idea, they're over 16 inches long. Don't need them this big, but I can't find my 7-inch model, so it's just a broken piece of wire just wedged up in there. I think this was the wire that was connected down here, because it has residue on the, and you won't be able to see, I'll need the camera will focus on that. There's residue on the end of it where it looks like it was connected to the resistor because it's burnt. So this would explain what this stuff is on the end of there's this sticky stuff right here. So I bet you this was soldered right here and this wire burned. And this might have been cut and trimmed when the owner tried to repair it, which is fine. Like I said, I always tell people you should try and repair it yourself. It will save you time and hassle to deal with shipping, and it's already broken. Normally you can't make it worse unless you drop it. And then we have the Humpty Dumpty scenario. So I don't see anything else inside. I don't see any other chunks of wire or debris, and there's nothing in there. So now these wires are really short. Even though when I shove them through, they come about halfway. It's gonna be really hard to get in there and solder them. So I am going to have to extend these wires so I can bring them out here a little bit so I can work on them better. The next thing I need to do is figure out this resistor. What was its value? Why was it here? I think it's a spike resistor, meaning when you first plug in a power adapter, AC adapter, sometimes when you plug it into your wall socket, you'll hear the little pop, or you see the arc of the electricity as it powers. That's a voltage spike, and it can voltage spike into the unit, causing problems. LEDs are not voltage spike friendly. They have a tendency of burning out prematurely. So in some cases they put in a resistor or a capacitor or some other small circuit to absorb that spike. Incandescent bulbs like this, they don't care. They'll eat it right up and not even think twice. But LEDs are a lot more sensitive. So need to figure out what that was. Let me see. So I'm running it at full 3 volts on my machine. What is this actually running with the light on again? I think it was like 3.5. 3.7. 3.7. And then let's do the free float just in case the light bulb burns out. We want to make sure the resistor is high enough that it can handle the load, but also not make the lights ungodly dim. .35. So this thing fluctuates 3 volts, and that's a lot. One nice thing about the 3 volts is these things don't get hot. So you can touch them as much as you want, and you won't have to worry about losing your fingerprints. So what I'm going to do is, instead of putting in another 1/8 watt, that's probably an 1/8 watt resistor, you can put in a 1/4 watt resistor or a 1/2 watt resistor. They're thicker and fatter and they can handle more heat. Since this one's burnt, which is hard to see apparently, let me rotate that. You might be able to see it right there. You know, pointing at it. I can't see it on the viewfinder, doesn't mean you can't see it on the computer or phone screen. But that's an 1/8 watt resistor based on its size. Instead of putting in an 1/8 watt resistor again, or even a 1/2 watt, I'm going to upgrade it to a 1 watt. I do have the other 1/8 watt and 1/2 watt and 1/4 watt. But I think it might be the voltage spike mixed with the free float. That the free float voltage is so high that the resistor couldn't handle the current. Because these purple lights, if they're real UV or purple lights, they can handle up to like 6 volts without a problem. But that resistor may not be able to handle the draw at 6 volts. And that's if this light was off or burned out. So Need to calculate it real quick. Let's do Ohm's law. And you can Google it online if you don't know it. It's just a math equation that let's use a inculator here and figure it out. So I'm going to put my source voltage in at 4, only because it's still 3 and change, just to see what it does. And 10, oops, 3, 10. It says a 100 ohm resistor for a 4 volt incoming power. So when you buy resistor packs, it doesn't matter what size you buy them in, they generally are labeled on the top. And now I just need to find the one that says 100. But Google Ohm's law or LED resistance or resistor calculator. There's 1,000 different ways to find it, and it'll give you the equations, and hell, half the time they give you the calculator. You just fill in the numbers you know, and it fills in the rest for you. It's pretty accurate. Usually it shoots a little high, which is good. Too much resistance on lights is better than not enough, because then you can burn them out faster. There they are. There's my 100. That's what I'm looking for. So, in case you can't see it, you can see it says 100R, means 100 ohm resistance. And you can see how fat these are compared to that guy right there. So, technically, should be good. But what I'm going to do is, instead of soldering and desoldering, connecting and doing all that stuff to the factory wiring, since again they're cut and I have to extend them, I'm going to add power back to this. Also, I need to mark which one's hot and which one's negative. And then I'm going to use the resistor in series with my meter or power supply, so I can make sure it's correct. Okay, that's hot. That's what I need to know. I'm just going to use a black marker, and I'm going to make this one black to indicate negative for me. So now I'm going to put my meter at the power coming in from the power supply. So that's the power coming in from the power supply with the light bulb on. You know what? Let's make this a little easier. Let's turn off some of these lights so it's easier to see. So that is what the power supply is putting out, 3.5, 3.6 volts with the light bulb on. This, let's bump it up a little, is what it is with the light bulb out. You can see it's brighter, but that resistor will handle this heat. Yeah, she's handling it just fine. So let's bump her back down to what the power supply is putting out, just right there. It's pretty close on the camera. I mean, this one's brighter than it is. This is because the camera is pointing right at the lens for the most part. It's at an angle, so it looks way brighter, and same with that one over there. But these are pretty close. The ones that aren't pointing directly at the camera lens, that's about what they look like in person. You know, change it a little bit if I block that, but now on some of the pieces, when I work on these, I do upgrade the resistors. And the reason I upgrade them to a little bit heavier model, I usually get rid of all the 1/8 watts and make them 1/4 watts or 1/2 watts. And the reason I do that is power supplies, when they fail, they can fail where they just don't work anymore, or they can fail to where they're putting in too much power. So if you put in one that can handle the excess power, you get a little bit more longevity, and you're less likely to destroy your electronics, or your lights in this case. It doesn't always work. It's not a guarantee. It's always going to happen. You don't have to worry about it. It's always going to never break, so on and so forth. Unfortunately, nothing is 100%. We're going to solder some extensions on here. I'm going to, while my soldering iron warms up, I'm going to move some of this stuff that I need on my bench. There we go. I have a piece of thinner wire right here, which should fit through the hole. Yep, plenty of room. Clean the tip. So we're going to start here with, now I know the wire is black and I'm putting it on the positive and the negative, and that's totally fine on the mark which is which once I solder them together. Twist them up. How I'm going to do that is I'm going to use the black for the negative and the red for the positive. Because once I feed the wires through the house, I won't be able to see the marker very well. Alright. I really need to check my chair. It's getting louder and louder, the squeaks. It's an old chair. It came with the house when we bought it. You're probably thinking, oh, he didn't put the heat shrink on and I'm soldering them together. You're right, but I have to cut the wire. So I'll put the heat shrink on once I cut the wire. Looks like I'll be cutting out about this much of the wire. So if you don't have heat shrink, electrical tape works fine. You can even use hot glue and make a ball of hot glue around one or both of the connections. But you just want to make sure they stay isolated from each other so you don't create a short. Stick one wire through first. So, and now we'll do the second wire. There we go. What was happening is when I was pulling the wire was getting a loop in it. And if you pull that loop, you can break the wire, especially these thin ones. There's a whole bunch of nicknames for them when you get those loops in the wire. Some are more vulgar than others. But one of the generic terms in the electrical field is a Foreman loop. And there's a few other, like I said, terms that are not so endearing. So basically what I was doing is I was moving it back and forth so I could get the wire to spin so I don't get a curl when I pull it through, because that's what it's basically doing. It's just curling over on top of itself. Looks like those ribbons for breast cancer and all the other different colors, because I don't remember them all. But that's what we're trying to avoid. So you just move the wire back and forth till you can get it to untwist, and then you're okay. But what I didn't do when I did this is this hot or negative? It should be hot. It is. So the resistor was on the hot side, which doesn't matter which side it was on, but that's pretty standard. It's always usually always on the hot side. So that way I know where to solder the resistor. So it's usually good to apply new solder when you're separating. That way you get a good heat connection. And that's why you'll see me add solder to an existing solder joint to separate wires. And now what I'm going to do is I'm going to put the resistor on here. Ooh. I'm going to solder the resistor on, cut off the excess, and then we'll use electrical tape to cover this connection. Although the other side will be completely covered with heat shrink, I'm going to cover this side with electrical tape just as a backup. In case the electrical tape, in case the heat shrink wears off, we just want a redundancy. That's all we're doing. Like that. Now we'll cut off the tail of the resistor that we don't need. That. And then this one has the red heat shrink. I know you can't see it because it's tucked up inside the house. So now you don't have to have these long leads on the resistor. You can trim them back. You don't, like they have medium length. So I usually trim them back after I solder, whether it's through a circuit board or in line like this. Just in case there's a screw up, I have additional material I can use. wire to twist on a little bit to hold her in place, like so. And here we go. Let that cool, and then trim off the excess. Apparently I didn't get all of it. Now I did. It bent on me. Yep. Well, when I just trimmed that last piece off, it made it really jagged. And that'll tear through your heat shrink. So I'm just going to trim the jagged piece off. There we go. That way it doesn't tear the heat shrink. And now we'll do the negative. So on the negative, I'm going to use heat shrink, which will cover the whole thing. I'll need a slightly bigger size due to the fact that I'm going to have 3 wires in it, not just 2. And I'm going to strip this down to brand new copper. 1, it'll be easier to work with, and 2, it's pretty jagged copper. They or not copper, pretty jagged solder. Jeez, they use lead-free solder, and I don't like it. It doesn't bond as well, and it gets brittle. There we go. So lights are on. So I'm going to do the same thing to this side. I'm going to trim it. There we go. Stay together. Thank you. There we go. And we'll apply some solder. Make sure it soaks through. So. Solder dripped on my mat. Normally it doesn't burn through, but that's one of the reasons I got rid of my last mat. Solder burns and just standard damage, warpage from the heat of the heat gun. And let me slide this over. Block the ceiling fan. There we go. So, you can see the lights are on. And now, I'm going to tape up the end of that, just as a redundancy, like I said. So electrical tape, I use Scotch 3M. It's the only tape I use. I found I've used different companies, different brands. I've used the cheap to the expensive, and I have the best results with the Scotch 3M. When I did custom car wiring, this is the only stuff I'd use. And even if the car had a car fire, this stuff was still there. Granted, it was sticky and nasty, but it's still there. And the reason I say car fire is the cars I was wiring up were used for movies, and they usually overloaded the circuits. Or somebody would mess with my wiring, and then it would short out and overload the circuit. So I'm going to try and tape these wires together. Come on, you do the twist. There you go. Nope, there's a jagged spot on the solder. Let's get rid of that. And we tape it up. So I'm not going to tape the resistor because the resistors have to dissipate heat. So I usually do not tape them up. Now, if it's something where I need it to be water resistant, I'll put some heat shrink over it. But I just need that solder joint covered so it doesn't arc if there's another problem. So this is a 100 ohm resistor, and I would, you don't have to use the half watt like or 1 watt like I did. I would go with an 1/8 watt instead of the 1/4 watt they use factory. That's just me. I do overkill. I'd rather have it stronger than weaker. Personal preference. Now I just need that to warm up. I'm going to put a tack of glue on the wires to hold them in because that's what they had originally. They don't just float in there. They'll get in the way of the light bulb. But while it's doing that, here's the resistor. You can see it's just black. It's black and gray. But you might be able to see that stripe. It's really faint. That stripe is a resistive wire that wraps around. And it got really hot. So now we just need to wait for this. So if this is your piece, if you have a power supply like I have, and I'll link it below, it doesn't take up a lot of room. It's about the size of a shoebox, so it's relative if you consider that big or small. It makes it easier. You can still do it with one of these lithium battery. This one's 3 volts. 3 volt. And technically, if you touch the 2 wires together and pinch it, those should turn on. They may not be overly bright because this may not have the amperage requirement to turn all of these on, but they should be dim. So if you're in a low lighted area, this is usually pretty good. If you don't have a lot of low light areas, the best place to do it is take it into your bathroom and then close the door. A lot of bathrooms, even if they have a window in them, are way dimmer than the rest of your house. So that's where I do most of my low light testing during the day, because my bathroom has no windows, so I can control the light in there. But that's a way you can test it without a power supply. You can use a 9 volt, holy moly, like this, but you need to get a resistor for it because this will smoke those lights. They will literally pop and burn out. Again, you just use a resistor calculator or Ohm's law to figure out the resistor you need to go from here to here. If I remember right, it's from here to the 3 volts. If I remember right, it's right around 680 ohms, give or take. Don't hold me to it, but I usually just use these or my power supply generally. And you can actually get a smaller power supply. The one I have is actually pretty large, but while I'm waiting for this to get warm, this is my smaller one of my smaller ones. This one I take out of the laboratory, so you can see it has an on-off voltage and current, which is your amperage. I know it's upside down, but it's just the way I'm holding it. You have your hot, your negative, and your earth ground. So if you have one of those straps, you can plug it in right here so you don't burn up a circuit board. It doesn't come with the automated clips. Some of them do. I believe this one did. My other one didn't. And if it doesn't, you can make them. Or you can just try and hook your wires right into it. But this thing you can see is relatively small. It's about the size of the house. Lengthwise. Widthwise, it's really narrow. Matter of fact, it's 3 inches wide with the 9 inches to here. If you count the leads and the power on the back, it's about 12. So it's a relatively small. And if you want to know how tall these things are, it's 6.5 inches. So this is a controllable power supply, and I have 3 or 4 of them. If not, you can buy one of these. They're relatively cheap. It's not controllable, but it puts out a constant voltage. Generally, they're used for lights or radios and stuff that don't have radios. So if you don't want to get a battery, these power supplies, they fluctuate from $40 to $80, depending on how fancy they are. That one goes up to 35 volts. The other one I have does, I think, 44. My battery died. Nope. So you do have choices. I still haven't opened this. There we go. But yeah, just a few options for you. But I'll put a link to one of those power supplies, that smaller one, and then the big one I have that's over here that I don't move. I even have a much larger one to the left of it. But it puts out up to 30 volts at 2.5 amps, and it has 2 outs. So I can have 2 different voltages that test 2 different things at the same time. You don't need anything that fancy. Heck, I don't need anything that fancy. But I got it from Goodwill for like $8, because I don't think they knew what they had. So you'd be surprised. But and they make other power supplies too. They make power supplies that have 12 volts out constantly, so you can just test everything in 12 volt circuit. They have variable power supplies like the one I was showing you, or you can just use a battery. And the reason I wanted to test the lights was if one of these LEDs shorts out, it can actually burn the resistor, and it'll start burning with a heavier resistor. It'll start burning the wire where the LED is bad. You can technically replace the LEDs individually. It's not easy. It's not hard. It's moderate. But the black caps on the bottom of these are just to cover the connections. They're just hot glued on. You can separate them, cut the leads really short, touch them with solder, and put a dab of hot glue and squish it back together and replace it with another light. The only problem with that is if this house was truly made in 13, like it says, the LEDs were probably made in 2012, and the lights today are probably made in 2024, 2025, which means the intensity and the hue will be slightly different. So you might have a light that's a different shade of purple, and it might be brighter or dimmer. And then you have to replace all of them. You can make your own string. I've done that before on miniature houses. You can buy fairy lights in purple and stick them back on here. They have fairy lights that have these LEDs, plus they have fairy lights that have the inline LEDs, the little small ones, and you can get them in purple, especially this time of year since it's Halloween season. When I was over at Michael's and at home, they had them both in this size string, the larger string, and the very thin fairy wire string, and they had them in purple, orange, green, and white, which I thought was strange, but so you don't always have to just fix what's on your house with OEM. You can put on one of the aftermarkets, and they usually come with either brown, black, or green wire, just like this, so you don't even have to do anything about the wire. If it was a Christmas light, there would be a white, most likely. And if it is the wrong color, they make paint. Alright, my glue gun's finally warm enough. Now, let's put a little bit of hot glue right here in the bottom, like so. And we're going to stick the wires into it, and I'm going to hold it without burning myself, I hope. And if you listen to all that discussion, thank you. If you didn't, I understand. option was just to pause the camera until I got this glued back together. If that was the case, I'd be talking to myself. Alright, so the glue is holding. I'm going to put a bead of glue around the flange where this light goes in. And make sure you put the light in the right way. And I'm going to hold it for a second. Oh. Alright, see what it looks like in low light. And there we go. If I set it back on its foot, you wouldn't see anything. But there you go. So the purple strings are all lit up, or string. Is it 6, 10 lights? Your 3-volt lights on, as you can see here. I like these houses. I didn't collect them when they were available, and I'm not a spider collector. My Halloween display doesn't have a lot of spiders in it. I don't have a lot of witches either. I'm more classical Halloween horror, Wolfman, Dracula, zombies, mummy, things like that. So the spider theme and the witch theme weren't a big thing because they're not the original style, and that's what I've always been into. But I still like the style of this house. They have several similar houses, like the one with all the eyeballs. I love that house. I wanted to buy it, and I kicked myself because I had one left. I didn't buy it, and even though it doesn't fit my motif, it's just a cool house. And that's what would happen to look like from above. You just see the edges of the lights. It's nothing there. So here's the side where you can see the one window there and the one window there, and we'll do the other side. Got the 2 windows. One's behind the tree. And then the back, where you got the 3 windows. So there you go. So, and lights are coming back. The house did come with the piece missing and the chips. And that's fine. It's, again, you can paint and touch it up. You can glue moss here. You can put whatever was here, a replacement of another tombstone just from a generic kit like what Lemax sells. So if you're one of the perfectionists out there, it happens. I got houses that are chipped too, or missing pieces, and I'll glue like a bush or a skull or something there. It doesn't bother me. But the important thing is getting their purple lights working again, and we got them working again. I'll link below power supply, both styles that I have. The big one that has the soldering attached to it and the heat and the voltage and everything else it does, because it's like 4-in-1 or 6-in-1. And then I will also link the other one. I'm sure you all can find batteries, the 2032s or the 2037. I have both of them up there. They're 3-volt lithiums. They will work the same. It won't be as strong because of the amperage, the current that the lights draw. The battery cannot keep up, so it'll be dim. Light strings, they're hit or miss. If I find some, I'll put them on there. If I can't, I can't. This time of year you'll find them, but that means in November, December, when you go click on the link, they'll be gone because it's Christmas, so there won't be purple. They'll be green, red, white. So, hot glue, you can get it anywhere, but I use Surebonder because it works better, at least I found. I'll link some heat shrink if you don't have any. Electrical tape you can buy anywhere. You can get the Scotch 3M from the auto parts stores and Amazon. I usually get mine on Amazon because I buy them by the tube, which is like 12. It's very expensive when you do that, so don't recommend it. You can use masking tape or even painter's tape, or I'll make a hot glue ball. It doesn't last as long, but there's a lot of houses out there that have masking tape inside of them, which is factory. They didn't use hot glue because at the time when they were making them, they're the older houses, the hot glue was more expensive than the tape. So anything you can use that you can isolate the 2 wires from touching each other, that's totally fine. But other than that, we're good to go. So that is the Department 56 Snow Village Halloween series. Trick or Treat Lane, the Spider House. Man, their names are so long. And that's how I test and fix the lights. And then again, I'll link a couple, but I'll try and link to different Ohm's law calculators and LED calculators. You know, you can just do a math equation on a piece of paper if you want, but the technology, there's no point on how to calculate the resistor you need if yours gets burnt. And then I would recommend, again, not using an 1/8 watt, but going up to a 1/2 watt or a 1/4 watt. I'm just going to go up to a 1 watt because the power free float is really high. I don't like the fact it's over 3 volts above what it should be, which means the power supply or the AC adapter could be going out, and in which case I just replace it since it just plugs into the back. But at the moment, we can compensate for it. So, the OEM1 won't focus on it. There you go. Spider House. Yeah, because this is 3 volts at 400 milliamps. So that's why that light bulb brings the power down, is because it draws so much power in comparison to the LEDs. Other than that, we're good to go. I'm going to get this box back up and sent back to its rightful owner. So appreciate you watching. Until the next one.